All right, this is the first free response from review day 2. It talks about a computer screen having two circles that start as dots and expand outwards, and they ask you three kind of different topics on that. The first one says, when the first circle has a radius of 9, it's increasing at a rate of 3/2 centimeters per second. At what rate is the area growing? So I'm going to do that here. This is a related rates problem. So we have to start with the area of a circle. Area is pi r squared. And then because we're talking about the change in the area, we're going to take the derivative. So dA dt is equal to pi times the derivative of r squared. So that's going to be 2 pi r times dr dt. Okay. If you did that correctly, you can give yourself a point. Then we want to put in the information they gave us. So dA dt when r equals 9 is going to be 2 times pi times 9 times dr dt, which was 3/2. And this 2 and the 3 will cancel, so we end up, or the 2 and the 2 cancel, so we end up with 27 pi. If you had that, give yourself a point. It does say to indicate units of measure, so this is change in area. Area would be in terms of square centimeters. And then per change in time, and they had it per second for the radius, so it'll be per second here. If you have centimeters squared per second, give yourself another point. All right, so not too bad, just straightforward related rates. B says the radius of the first circle is modeled by this equation. At what time is the radius increasing at a rate of 3 centimeters per second? So they want to know, when is the derivative, the rate of change, equal to 3? So the first thing we're going to do is take the derivative of that. So w prime t is equal to the derivative of 12, which is 0. So then we're going to have negative 12 times the derivative of e. E repeats itself. And then times the derivative of that, which is a negative 0.5. And if you simplify, it turns into a little nicer problem. Negative 12 times negative 0.5 is 6. E to the negative 0.5t. If you had that derivative, give yourself a point. Then the question is asking, when is this increasing at a rate of 3? So they want to know, when is this derivative equal to 3? So we set it equal to 3. And believe it or not, if you just took your derivative and set it equal to 3, you got a point for doing that. And then if we divide by 6 and then take the natural log of both sides, and then multiply by negative 2, we end up with t equal to negative 2 natural log of 1/2. And that would be worth a third point. So again, not too bad. You just got to understand what the question's asking. As long as you kind of navigated that, that one wasn't too bad either. Last question says a model for the radius of the second circle is given by this equation. Here's the derivative. They want to know, how much did the radius change from 0 to 3? So how much something changed is the integral from the start to finish of its rate of change, in this case the derivative. So we're going to integrate the derivative here. So that's going to give us t cubed over 3 minus 4t squared over 2, so 2t squared plus 4t. And we're doing that from 0 to 3. So if you showed this integral, just had that set up, that was worth a point. If you integrated it correctly, you got a point. And then if you put the 3 in, 3 cubed divided by 3 is 9 minus 2 times 3 squared, so 2 times 9 is 18. And then plus 4 times 3, that's 12, minus, and then the rest of it is going to be 0. So we end up with this minus 18 plus 12, that ends up being 3. And if you had 3 as your answer, that was worth a third point. So not too bad. Again, you just got to understand in each case what they're asking you to do. But otherwise, you could get a lot of points on this one.